Welcome back. These are the chapter 8.3 notes, inverse trigonometric functions. So first thing we want to do is review, okay? An inverse function. An inverse function takes in y and returns x. Okay, the xy we're talking about is in our original function. So when we talk about inverse function, we are talking about functions that undo our original function. So if you need it a different way, they undo the original function. What must be true for a function to have an inverse? The function must be one-to-one. And we'll talk about that a little more in just a minute. How can we tell if a relation is a function? Every x gives us only one y. If the function is one-to-one, then every x gives us only one y. And every y gives us only one x. So this goes both ways. And let me fix that. Okay. When we talk about trig functions, things look a little different because of the way that the trig functions look. Because of the fact they're periodic, because of the fact that those y values repeat over and over and over, we have got to fix things for us so that we can have an inverse trig function. Okay? So a couple of things to remember first off. With our trig functions, the domain is going to be the measure of the angle, and the range is that ratio, the number that goes with it. You know what I want to do? In our inverse trig functions, our range is now the measure of the angle, and our domain is the ratio, right? We're taking in the y and spitting out the x. Okay. We write those inverse functions as f to the negative 1 sine to the negative 1. Be careful you don't read that as a reciprocal function, as a 1 over. It's not a negative exponent. That's how we write the inverse function. Okay. So in order to make this make sense, let's take a look at a couple of examples. A here, sine of pi over 6 is 1/2. Pi over 6 is in the first quadrant, so both sine and cosine are positive. So our inverse sine of 1/2, we're taking in that ratio, is going to be pi over 6. For B, the cosine of pi is negative 1, so if we're going to go the other way, inverse cosine of negative 1 has got to be pi. And for C, the tangent of pi over 4 is positive 1, so inverse tangent of 1 is pi over 4. Okay. That's great, but we know that there are symmetries in our unit circle. And so let's take a look at D. Do we have another angle that would have a sine of positive 1/2. And I'm going to pop to page 2 here because there is a unit circle. Sorry, I have a Band-Aid on my finger, and so I'm having trouble blowing this up. So we have sine is positive 1/2 for pi over 6. But in quadrant 2, our signs are also positive. So I'm going to come back up here and we're going to answer this question. And I'm going to write it this way. The sine of 5 pi over 6 is also 1/2. So that creates a problem. If inverse sine of 1/2 is what I want an answer for, I cannot have two outputs. Okay. Second question was about our tangent of 1. Tangent's going to be positive 1, where our cosine and sine are the same. That also happens in quadrant 3. In quadrant 3, I have a cosine and sine of negative square root of 2 over 2. So at 5 pi over 4, our tangents also 1. So this causes a little bit of a problem for us. Why does this matter? Because each input should have only one output. And so we're going to take care of that in a minute. So each input should have only one output, not two. So each of those ratios should only give us a single angle. And we're going to take care of that in just a minute.